Hi everybody, in today's video we're going to take our player that we've built here and we're going to add a player state machine complete with placeholder states for idle, run, jump, fall, and crouch, and we're going to hook up just the basic implementation that we need so that our player can fall and land on the ground and idle.
Hey, Michael here. Throw on your favorite game dev tunes and join me as we build a 2D platformer in Godot 4 using GD script.
Alright, so where we last left off with this project, we have Marlowe able to play animations and he's a nice little entity, but obviously he doesn't fall, he doesn't move, he doesn't do anything. And so what we're going to focus on today is building the script, and in particular we're going to build a state machine. If you are new to that concept, then I hope that this eases you into it just a little bit. The importance of a state machine is that it allows us to kind of break apart our code so that, each different action that the player can perform that's, separate from each other gets handled by its own piece of code. And this brings with it a lot of benefits in the ability to kind of decouple things. It makes debugging a lot easier because, if you're having an issue when you're running, then it's within the run script and it's not affected by something else. And it's just going to keep our main player script file pretty simple and clean. But what I would like to do then to begin is let's create our first script in this project for our player. Okay, so get your player scene open like I have here. And what we're going to do is we're going to go ahead and create a new script. And there's a couple ways you can create a new script in Godot. The simplest way is to right click on the node here and just find this attach script option, and we'll click it. Now what this is going to do is it wants to drop it into this player folder. It's going to say that it inherits character body 2D, which it does. That is the node type that this is based on. And that's very important with our scripts so that it, when we're writing them, Godot knows what kind of object we're manipulating and what kind of parameters and functions we have available to us within that script. One thing I want to do though is I want to change the path. I'm just going to click in here. I have a scripts folder. Let's go ahead and put our player script in that script folder. That's going to keep all of our stuff nice and organized. Okay, so now I can create that script. It'll create it and it'll open the script in Godot's in-engine script editor. And this is what we've got right here. And you can see that all it says is extends character body 2D. I want to give this a class name. So right before extends, I'm going to say class name and I'm going to call it player. This is going to make it easy for us to access this script and its members in other scripts that we write. If you don't have that class name, then you lose a little bit of assistance and help and even a little bit of functionality that you could have. Okay, so that's kind of an important little step. Go ahead and add that there. Now what we're going to do is we're going to set up Marlowe in this player controller so that he has the ability right now just to do some really basic movement and to fall. And then we're going to set up a state machine that we'll use in the future tutorials to build all of more advanced functionality in for our player. So before we do that though, let's go ahead and let's do a few things. In this script file, we can define variables, we can get access to nodes within this scene's node or scene tree, and we can also define functions that do things and hook into some of the Godot functionality like the physics process, which we're going to use today. Okay. And so first, let's go ahead and just define a few variables. I'm going to start with a variable that we call move speed, okay? And this will be a float. Now I have a practice of doing static typing in Godot, meaning I always put colon and then the type of the variable. This provides some small performance benefits, but it also provides benefits while coding, because if you have a strict type for your variables, then you can't accidentally assign it the wrong type of value. Okay, so this is actually, in my opinion, something really important and critical and something I'm glad that Godot supports. I'm going to just set this to 100 so that we've got a variable here called move speed, and it's 100. I'm going to make another variable for the gravity on our player. Okay, this will also be a float. A float is a number with decimals. Even though I'm not using decimals, that's the kind I want. I'm going to set it to 980. 980 because, gravity is something like, I can't remember, 9.8 would be maybe a standard gravity, right? 9.8, whatever gravity is. But because we're doing like pixels and really small, I'm just going to scale this value up. Otherwise, our game's going to feel really slow and floaty like you're on the moon. And then we're going to grab a few things from our scene. So a few things that we want to be able to manipulate in our game is we have all these animations set up, and those are here in the animation player. We also have our sprite, which we may want to make changes to. Okay, and then we've got an audio stream player, which we want to use that to be able to play audio. Let's go ahead right now and just grab those 3 items. You can see I'm just holding Shift to select them, and then I'm going to click and drag, and then while holding Control or Command if you're on a Mac, I'll let go. And that's going to plop these in here with this onReady decorator or syntax, which means when this script loads, then grab these, and we're going to basically say, okay, find the node called sprite2d and assign it to this variable so we have easy access to it. Same with our animation player and our audio stream player 2D, right? Just get a reference to that node in the scene, and now that's accessible through our script with minimal code. One last thing that we want to do is we want to set up our ready function. You almost always need a ready function, and it starts with an underscore, I guess. And what the ready function in Godot is much like that onReady decorator. You know, as soon as this script loads, then find these things. Well, this ready function runs when the script loads, okay? And it'll run after it grabs these. Okay, so we have our ready function. I'm going to just type pass on the line there. What pass does is says, I don't actually have anything in here, but it ends the function for us so that we can have a valid function. Otherwise, if we leave it blank and go on, you can see that it's expecting an indented block and some sort of function declaration, right? So our function right now is do nothing. That's not going to make any change, but you can see that this player now has the little script icon here, right? And what's nice is if I were to close this script, right? Anytime I'm working on this, if I need to come in and edit the script, I can just click that, pops it right open. And then if you need to find out where the script is located, you could right click here and you can say show in file system, and that'll just open it up here in the file system panel. Okay, so with this in place, when I run the game, still nothing happens because we're not doing anything in our script. But this script is what we're going to use to add all of the control functionality to our player. This script and some other ones that we'll build. Okay, and I had mentioned earlier something called the physics process. So within Godot, if you're new, there are 2 types of processes. There's the regular process, which happens every frame that the game draws or is run. And then there's the physics process, which runs every time there's a physics process that happens. And those 2 are separated for a particular reason. Your game might be running at 60 frames per second or at 30 frames per second or maybe at 300 frames per second. And any code that we have in the process function will run at that rate. You know, if it was at 30 frames per second, well, then it's going to get called 30 times per second. Or if it's 300 frames per second, it'll get called 300 times. And that's great, but for certain things like physics, we don't want it to be variable like that, because let's say you're moving the player by a certain number of pixels per frame or something along those lines. If you do that in physics process, that means your speed of your player will be faster if your computer runs the game at a higher frame rate, right? And then if your game struggles to run the game, it's like 12 frames per second, then your movement's going to be really slow. And so physics process is designed to help circumvent some of those problems, or at least that's part of why it's there, because it happens at a fixed rate. 60 frames per second is the default. And so we will do anything with our movement on our character body 2D within the physics process function, because that's what it's designed for. It's to handle these movements, to handle collision and things like that. So we can go ahead and hook into that function just by typing func_physics process. I'm going to go ahead and add that pass. Now you'll notice we got in here this delta value that it automatically added. Delta is the time, like actual time in seconds or, milliseconds since the last process ran or the last frame. And that's pretty useful. If you don't reference this, you'll get a warning in your script. So I'm going to go ahead and run this real quick just so you can see that. In my debugger, I've got an error. It says that the parameter delta is never used in the function physics process. It does give us a tip of how to fix it. If this is intended, prefix with an underscore, such as this, _delta. So I'm going to stop running my game. What that is saying is like, look, you have an argument in this function here, but you're not using it. So it's basically inviting you to remove it or to put the underscore. But if we remove it in this case and run, it's not going to work. We're going to get an error because this physics process is expecting that delta to be there. Okay? So let's just go ahead and give that an underscore. That'll clean up the warning and prevent us from having that in the future. Just one last quick example. If we run, the game ran just fine and we didn't get that debugger warning. Okay. So what we can do here in the physics process is let's go ahead and let's make our player fall. And this is going to be really simple, actually. There are two things that we can interface with that already exist on the character body 2D that'll help us do this. One is a built-in function called move and slide, just like that, okay, with underscores. And what the move and slide function does is, we'll go ahead and click on it. It says it moves the body based on a velocity, okay? So we can assign a velocity to our character body 2D, and then whatever the velocity is will be used in this move and slide function to move the character. And it also handles collision. And we're not going to get too much into those, but that's really handy because that gives us stuff like he should land on a platform, right? So going back to our player script, just doing move and slide on its own is not going to move the character because remember it said it's based on a velocity and we're not setting the velocity. So right now the velocity is 0. So let's just go ahead and update the velocity here in the physics process. And what we're going to do is we're going to only manipulate the, oh man, I cannot type velocity. We're going to manipulate the y of the velocity because the velocity is a vector too. Think of it as in two directions, up and down and left and right. Okay. And so there's two coordinates, you know, so if you've done math and you've done graphs, same kind of thing. So we're going to just edit the y component, which is the up and down component of the velocity. And we're going to just say, we could just set it equal to maybe 100. And if we run this, then the player is moving down at a rate of 100. It's roughly 100 pixels per second, I think is what that'll come out to. But we want this to be a little bit more dynamic than that. So I'm going to come in here and I'm going to change this. With gravity, you know, you have this nice easing of motion because gravity increases the speed that an object falls over time, right? And so when an object, if you were holding a rock and dropped it, it would start at no velocity and then increase due to the force of gravity. So to simulate that, what we could do here is just say velocity y plus equals. So instead of setting the velocity, we're going to add a number to the velocity. That's what plus equals means. We could add the gravity. This isn't going to work quite right. Let's go ahead and run it. And we'll see. It should be really fast, I think. Yeah, you didn't even see the fall happen. It was so fast. The reason it was so fast is because, remember, this is running 60 frames per second. So this is where this delta value comes in handy. I'm going to copy that. We can just take our gravity and multiply it by the delta. Okay, so now we're saying, okay, change it by the gravity, but assume that the gravity has only affected the object for this amount of time, whatever the delta is. So when we run this, boink, that looked pretty good and pretty accurate, right? We can't do anything, we can't jump, but there we go. Now we can fall. Likewise, we could come in here and we could manipulate the player's movement on the x-axis by altering the velocity. And so let's just go ahead and just set our x velocity. We'll just set it to a static number like 100 again, and we'll run this. So he'll be moving towards the right. Okay, so you can kind of see how this would work, right? Now, if we wanted this to happen only when we press a button, we would begin coding that. And this is where we're going to really quickly transition into doing a state machine. And let me just describe the problem briefly. If we just have simple functionality like falling and walking, there's only a couple checks we would do, you know, like if the player is pressing the left key or the left direction, you know, then change the velocity this way or that way. And then we'll have conditions in there for jumping. And then maybe if they're pressing down, they need to crouch. And then maybe if they're holding the action key that we have set up, then they should be running at double the speed. And you can see how the amounts of checks are compounding. And if we do all of those within this one physics process, then it's going to get really overwhelming. We could break that out into different functions within our player script, and that would help consolidate that. But we still want a way to be able to consolidate and separate the concern of each state into its own script. So that's why we're going to dive straight into building a state machine, and we're not going to mess around a whole lot with just doing stuff here in the player script. So let me just delete that here. We'll keep this player velocity in place for right now. Eventually we'll modify this a little bit, but this is good as is. Okay, so what a state machine is just what I've been describing, right? It's a script that we'll write that allows us to select one state for the player to be in at any given time, and to only execute that state's functionality. And we're actually going to be building a state machine that's also somewhat visual. It's going to live in our scene tree for our player. So you're going to be able to see the states and even select each state and manipulate some of the parameters. So let's say you want to adjust the movement speed. You can just do that by selecting the state from our state machine here in the scene tree and modify the values as needed. So let's add a new child. And I'm going to go ahead and just make this a node 2D. Oftentimes we would make this a regular node, but I think node 2D provides a minor benefit in this case. And I'm going to rename this node to be called player state machine. Okay. And then underneath this player state machine, I'm going to add a few other nodes, and they're going to be node 2D as well. Okay. And we're going to make a node for each state that we want the player to be able to have. So I'm going to name them idle. And then I'm going to just hit Control D to duplicate and rename this one to run. We'll have a jump state. Now, typically in games, you might just have a jump state on its own that handles like falling as well, but I like to have a separate fall state for this demo. You're going to see how it allows us to keep our fall and our jump a little bit separate and cleaner. And then one last state that we'll add in this project is going to be the crouch state. Okay, and so these states here, idle, run, jump, fall, and crouch, these are the 5 states that we're going to build across this series. And each of them are going to have their own script, and they're going to be controlled by and toggled by the player state machine, which means we need to add a state machine script to this player state machine. So I'm going to go ahead and expand this state machine folder, and I'm going to make a new script in here. And it can extend a node 2D. And I want to call this script, this is another way of creating a script, right? Before we right-clicked on one of the nodes and just added one, and you could have done that as well. But I want to call this the player underscore state machine, just like that. Make sure it's got .gd on the end, and then we'll create it. I'm going to go ahead and open this script. Now you can see that this script extends node 2D. I want to give it a class name as well. Player state machine. Oops, I accidentally removed the extends part. Okay, so the name is player state machine. It extends a node 2D. I'm going to go ahead and drag the script onto my player. Well, actually, hold on. Before we do that, I want to add one other thing to this. Now, I want to give this node a special icon so it's easy for me to find in the scene tree. Okay, and as you recall, one of the assets that was brought in with our game, it's going to be under our player here. We've got sprites and we've got this icon state machine 16 by 16. Okay, just a little icon that we'll use to put on our node. It'll replace this little blue circle here. In order to use that in the engine, we just can add a special line to the top of our script and just say @icon. And then here within these parentheses, we just put the path to the icon we want to use. We can actually just click and drag and drop that file in there, and it'll populate the resource path for us. So now I can save this script, and when I drag this script onto my player state machine, and it looks like it didn't assign the icon, but let's go ahead. I'm going to just reload the scene real quick. Reload save scene. Make sure it's saved before you do this, because it will reload whatever was last saved. Well, that didn't work. It didn't actually apply the icon. I'm going to go ahead and reload my project. You can do the same if you want to. So project, reload current project, and it'll just take a moment. There we go. You can now see that our player state machine is using that icon in the scene tree. That's nice because it makes it easily distinguishable, easy to find. And I don't know why these don't always update very well in Godot. I wish this was one thing that they could kind of refine a little bit, but pretty minor gripe, especially with how quickly Godot can reload. But there we go. We've got a state machine script. Now, what does a state machine do? The state machine script is the script that controls it. And so it needs to be able to have a reference to the scripts or the states, or at least be able to track what state we're currently in. Sometimes, and in our case, we're going to want to track or have a way to find the state that we were previously in. And we'll keep, in fact, an array of states that we've been in. And the state machine will also be responsible for kind of setting up those states and then running them if it's the active one, okay? And you'll see what I mean as we go through the script. Now, before we're ready to add anything to our player state machine script, we also want to create the player state script, okay? Because its functionality is going to be used extensively within this script. Okay, so down here, under state machine, I'm going to create a new script. And it can go ahead and extend a node 2D. And I want to give it a name of player state, I guess. So we'll just call it player underscore state, just like that. Now we're not going to assign this player state script to anything. Okay, this player state is more like a template for what a player state can and should be able to do. So let's give it a class name like we have been doing. We'll call it player state. Extends node2d is just fine. Now this state script is the script that's responsible for what happens when I'm in this state. It'll also be responsible for what happens when I enter this state, right? When it begins and when we exit or end the state, as well as maybe things like input handling and things like that we'll do from within the state. So let's flesh out this script real quick and we'll put together the basic template. Now we're going to have a couple variables and we're kind of diving into the deep end on some of these things here. So, if you've got questions or concerns or not sure what something means, go ahead and drop a comment in the comment section below. Also, if you really want to, you can join my Discord channel. That was also linked in the description. And inside my Discord server, there's a channel specifically for this tutorial series. So please hop in there, start the conversation, and help each other out. We're going to make some special variables that we call static. And the first one we'll make is called player, and it's going to be referencing a node of type player. Now, what a static variable is and what a variable is, I guess, if it wasn't obvious, a variable is essentially just like something that's storing a piece of data. We give it a name, we tell it what type of data to store, and we store it and we can reference it in code by accessing that name. Now, when we say that something is static, at least when a variable is static, that means it's shared with any instance of this class. And so what we're going to have is we're going to have like a new state type that'll be called state idle or something like that, right? And it will extend the player state. Much like this player state extends a node2d, our other states will extend player state. And when we have a static variable, when we assign it in one instance of the class, they all have access to that same defined version of the variable, okay? So this is a way for us to share a variable across all states. Because obviously, once we set the player on our state machine, all of the other states should be able to have access to the player, and we don't want to have to set it per state, okay? This will just clean that up. Now, we're going to have two other static variables. One will be a reference to the state machine itself, which is type player state machine, okay? And then the last static variable that we're going to define is a direction, because many of our states are going to need to know what direction we have from our input from our controller. And so we'll just share that amongst all of them because that'll simplify our states a little bit, okay? And so this direction is a vector2, right? So it's got two directions, left and right, or the x coordinate and the y coordinate. Now, we're also going to eventually drag in a reference to every state type here. So once we define them, we'll plop them in here. We'll do that in just a little bit. And that way, again, states will have access to each other pretty easily. And then let's go ahead and set up. So our player state should have it could have a ready function. We don't really need to define this here, I suppose, but we're going to. Oops, I meant that to be an arrow. And within our player state, we're actually not going to make most of these functions do hardly anything. We're just going to define them because this is, again, like a template for all of the other states, okay? So then the next function that we're going to need, we're going to have an init function. This is going to be just in case we need to do any special code when this state is set up or initialized for the very first time. We'll also have an enter. Now, the enter function is going to be used by virtually every state. This is like, hey, if I go from walk to run, when I enter the run state, what should happen, right? That's what this function is going to determine. We'll also have one for exit. Also useful in just about every state that we'll have. And then we're going to have three other special functions that we're going to use and hook into. So within Godot, we've already talked about the process and the physics process. And so we want to define within each of these what happens in that during the process or the physics process. There's a third Godot kind of hook function that we haven't talked about, and that's when we have an input into the game. Okay, and so we're also going to want to handle inputs within the state. So let's go define this first one. We'll call this function handle input. And you can see it's saying, do you mean unhandled input? Nope, we're going to do that somewhere else. But in here, we'll handle them. And this handle input function is going to be a little bit different in a couple ways. First of all, in these parentheses, we are going to expect an argument. What was the input event? And so we're going to call that event. And it's going to be of type input event. And also this function, as well as the next two, are going to return a value. So when we do this little arrow void up here, that means this function doesn't return a value. Returning a value means, like, if I call this function, and I just noticed I spelled exit wrong. So if let's say I had a function that was like add 2 plus 2, and when I ran it, I expect it to return me a number, which would of course be 4, but you could say that it should return a number, right? Or an integer was what that would be in Godot. Then that means that this is supposed to return a value. And if it's void, then it's not going to return a value. We want these other functions to actually return a player state. And you're probably asking yourself, like, what does that even mean? And so by default, it needs to return something, and we'll just return null. So that means that these can return a value, either null or a player state. Okay, and so let's go ahead and define our last two functions. We have our process function, which, much like the process in Godot, it'll have a delta value, which is a float. And this function will also return a player state. And so we'll make it return null by default, because it needs to return at least null. And then we'll have a physics process. And you notice I'm typing my process and physics process without an underscore, and that's the primary differentiator between the name. And so, like, if I were to say physics process like that, I don't want this underscore physics process, because we're doing our own type of physics process that has to return, again, a player state. Okay, so this is the template for any of our states. And we'll get a little bit more into this. This player state's going to make more and more sense as we develop the code. But for right now, we just need to have this defined and ready to go. Okay, now that we've got that player state set up, let's go ahead and go back to our player state machine script. And now we can start defining some of the stuff in here. Now, I had mentioned that this is going to keep track of our states. So we'll make a variable that we'll call states. And it's an array. And I'm putting these brackets here because I want to specifically type it as a type of player state. Okay, that means anything that we store in this array is going to be a player state. We're also going to have a value for current state, which will be a player state. And what this is actually going to do, because we're going to have states stored in this array, this is just going to be a simple variable that we'll use to be able to call and get whatever the current state is, which is going to be the first one in the array. And you'll see how we build this, but I'm just going to change this function. It's going to do something different. I'm going to put another colon here, and then on the next line, I'm going to type get, and then I'm going to say return states, right? This states variable, and then dot front. And what this front does, let's go ahead and click on it. It returns the first element of the array. And if it's empty, it returns null. But it should never be empty when we actually use it in code. I'm going to make one other variable just like this that we'll call previous state. Also of type player state. We'll also return, using this get, we're going to return the state at index 1. Now, one way to look at this is front, right, returns the first element of the array. And you'll notice that array 0 is another way we could get that. Arrays, and generally this is something you're going to run into in programming, when you have, a list or an array or something like that, the first item is at index 0. That's just how it's done, right? And so item 1 is at spot 0, item 2 is in spot 1. Okay, and so when we say we're going to return states and then in brackets 1, that means get the state in slot 2. I know that seems confusing. If we said 0, it would return the first one, and that'll return the second, okay? And so that's how we're going to return and get our previous state. And we're only going to use that probably once in the course of this tutorial, of this series, but it'll be very useful when we do. We're also going to want a reference to our player here, just so we have it when we need it. Okay, so those are the basic variables that we need within our state machine. And we can go ahead now and set up some of our functions. We're going to have a ready function. And this ready function is going to do one thing, and it's going to disable our process mode. The process mode, when we talk about having physics process and things like that, That's the process mode. It's like, how do we handle process updates with this? And you can see here after I hit equals, we get a couple recommendations. There's always, disabled, inherit, pausable, when paused. And what we want to do right now is we want to disable this node, because we don't want any of the process code that we're going to write to run until our state machine has all been set up and fully initialized. Otherwise, we'll run into some errors. Okay, but that's all we're going to do in the ready function. And you don't need to put this pass line. I just like to, because it's a nice, clean, pink indicator that the function is ended. And obviously, if we're saying that we're going to use the process mode at some point, we'll tie into it. And we're going to use the underscore process. So this is Godot's process mode. And I'm going to go ahead and add an underscore to the delta, even though we will use it. I just like doing that as a habit. Okay, so we're going to do some stuff in the process mode. And we're not going to fill that out just yet. We're also going to have a physics process, okay? And again, this is the Godot's version of a physics process, just like we used in the player script. And remember, we had that other thing that we set up in our player state. It was called handle input. Let's go ahead and set up here. There's and we saw it in the tooltips or the autocomplete tips earlier, but there's an unhandled input, okay? So we're going to reuse this unhandled input function. And what this essentially does is says, hey, do we have any inputs, any button presses that haven't been handled yet? And if so, maybe we want to handle them. We'll see if we can. Now, what's interesting is all of these are going to just handle some code. They're going to handle code from our current state. And then remember, the state returns a state or null. So essentially, in each of these, we'll just check. We'll say, hey, run the state's code. And if it tells us we need to change states, then let's change states. Otherwise, we won't. Okay. And that's going to kind of happen within each of these three calls here. And in order to make that possible, we're going to want to set up a function for that. So we're going to have a function that we call change state. Now, this change state function is going to expect a potential new state of type player state. Okay. And this can return void. And we're going to need one last function here in our player state machine script, and it's going to be an init function, just like we have within each of our player state scripts. And what this will do, I'm going to go ahead and put an argument in here. We're going to need a player, because before the state machine is set up, it's not going to have any access to our player scene. So we'll provide that within this, and then we'll handle that. And let's go ahead and set up this init function first, because this is kind of the first thing that will happen. So the first thing that we'll do here is we'll just take our player, because as you recall, we defined a player variable within our script. And we'll just set it equal to the player that we passed into this function. Okay. And then we'll go ahead and initialize our states as an empty array so that we can start working with it. Now, what we're going to do is we're going to go through, our state machine is going to go through each child node, and it's going to just add them to the states array, okay, assuming it is a player state. And so what we'll do is we'll say for C in get children, which is a nice handy function in Godot that just gets all of the child nodes in the scene tree of the current node that we're on, right? So in this case, it's going to get all these. Then on the next line, it needs to be indented. We're going to check, is C, so when we say for C in children, it's going to go through each node and it's going to assign it to this C variable. So we'll look at it one at a time, and each one we'll just reference as C. So if C is a player state, because it needs to be a player state, then we can add it to our states array. So states, now to add to an array, it's append is the function we use, and then we can just append that node. And let's go ahead and just get this far. Right here, I'm going to just print, and I'm just going to say like init found, and then outside these parentheses, I'm going to type a comma and just say states dot size. And then I'll put states again in parentheses, and I need another comma here. Okay. So I'm going to save this. We've got this init function halfway set up. We need to do a little bit more work, but I want to go in here to my player, because we're going to need to actually call that init function and pass the player into it, right? So here in our ready function, and actually before we do this, let's grab a reference to our player state machine, because we don't have access to it. It would be nice to. So I'm just going to drag that. Remember, drag and drop while holding control will add this reference. Okay, so now I'm going to take my player state machine and I'm going to call the init function. Oh boy, if I could type, and it's showing up right there. And you see, it's expecting a player to be passed in. Because this script is a player, I can say self. I'm going to pass myself in to this function. There we go. So that should call the init function on our player state machine, which should eventually print this to the console down here. So let's go ahead and just run that and see what happens. Init found 0 states. We have 5 nodes here, but none of them have a state script assigned. So that makes sense that it didn't find any. Okay? But that means this is working to some degree, right? Let's go ahead and finish this init function. After we've collected all of our states within this state machine, we do need to go through and call the init function on each of those. And we also can set the values that we have in our player state. Remember, we've got these static variables, player, state machine, and direction. We want to set those on the first state in our array so that they all have access to it. So back in our player state machine, let's go ahead and just try this, and we'll say states 0, that's going to be the first one. Or actually, we could say current state. We have that function, don't we? Or that special property up here, current state. It'll give us the first one. So we'll say current state dot player equals player, and current state dot state machine equals, and again, this, just like we did with the player, this script is the state machine, so we can say self. But this is going to give us an error. I'm going to save it and run it. Because it's saying invalid assignment of property player with value of character body 2D on a base object of type nil. Now you're going to see messages like this all the time in Godot. And essentially what it's saying is like, look, we tried to put player on this object that doesn't exist. And it's talking, when it says an object of type nil, it's talking about the left side of this equation. It's saying that our current state doesn't exist, which makes sense, right? Because we just printed and we found that we didn't find any states. Okay, so let's go ahead and handle that. Later on, we will find states and then it'll work. So let's put an if check. If states dot size equals 0. Okay, if there are no states, then we will return. Now, if we run it again, we shouldn't get that error. Good. Marlowe fell. Nothing else happened. But at least we've avoided this little bug where we can't assign those. And once we get some states in there, it'll work. The next step that I already mentioned was we're going to go through all of our states. So we're going to say for state in states. Okay. And we just did this earlier, a for loop, right? So we're going to go through each of the items in our states array, and we'll go one at a time, and they'll each be called state. When we do, we're just going to call the states init function, just like that. That way, if that state machine needs to initialize itself, it will. And then lastly, we'll do 2 things. We'll call our change state function on the first state, because we need that first state to enter. Okay. And you'll see how this works here. No, I don't need to do state 0. I keep wanting to do that, but we have this current state we can use. Okay, so we'll change state to the current state, and then we'll enable our process mode at the end of this. So I'm going to say process mode equals, and then we'll say inherit is the one that we want. Okay, that's the default way that it works. So this code is going to go through, it's going to get all of our states. If there are none, we'll end the function right here. If not, we'll assign the player, the state machine, and call the state's init functions, change to our current state, and then enable everything to start working. Now, once we say process mode equals this, right, then it's going to start processing. It's going to start happening, and happening every frame. It's going to start hitting these functions. Now, because we don't have anything in change state, right, that's not going to do anything. So let's tackle change state next. Okay, let's go to this change state function. And so the change state function is going to be pretty straightforward, but a few lines of code. So the first thing that we can do is, obviously we're passing in a state, right? We want to do a check just to be safe that anytime we call this function that we actually have a state. Because as you recall, the player state functions, we're going to use this to determine what the next state is, and it can return null. And so we're going to have to handle that option all the time. And so the first thing we should do is just say, if new state equals null, that means we don't need to do anything, so we'll just type return. And if you haven't figured it out yet, return just like ends the function right there, okay? Or it returns a value. In this case, it just ends it. And then next we'll say elif, we're going to do another check, because there is a slight possibility that the new state is the same as our current state. Okay, so 2 equal signs says is the same as, okay? So if new state is the same as or equals the current state, then we will also return. And then what we're going to do is we have to go through just a couple basic steps. When we change states, we exit the current state, we bring the new state in, make it the current state, and then we enter the new current state, okay? And we'll just check if there's a current state. This shouldn't really need to happen, but I think this is important to just check. So if there is, then we'll go current state.exit. We'll call the current state's exit function, okay? So hopefully this is starting to make a little bit of sense, right? Whatever we end up putting in our exit for like the idle state, when we go from idle to run, it's going to call, okay, do all the stuff in the exit state real quick. And then after that, we'll say states.push front. So we're going to add a new state item to our state array at the front, because the front is where our current state resides. And in here, we'll just pass in the new state. Okay, so that now current state's going to now return whatever the new state is, right? Because it returned states.front. And then we can just say current state.enter. Just like that. So it'll call that state's enter function. And then I'm going to do one more thing here. And I'm going to say states.resize. Because if we don't resize this, our states list or array is going to continue to grow. And it's going to get really big, really quick. And we don't really want that. So I'm just going to resize it to 3. I'm going to say we only keep track of 3 states at a time once the game gets going, right? So we'll have the current state, and then the previous state, and then one previous state after that, which I don't know that you'll ever need. And if you needed more, you could keep that larger. But what this resize will do is, we'll go ahead and look at the description. It sets the array number to the size that we pass in, and if it's smaller, then all the elements after that number are removed, okay? So if we had 4 items, it would just take that 4th item and chop it off. Okay, so that's what we have for change state. That's the entire function. Now, one thing that we can do in here is we can print our states, and this will just kind of be a nice way for us to see in the console what the current state is or what this array looks like, okay? So I'm going to put that in there, print states, just like that. But we still don't really use this very often, partly because we don't have any states assigned. But before we assign a script to a state, we need to finish our state machine, okay? We need the state machine to have all the code that it needs to be able to run these states, and we're actually getting pretty close. So we'll just finish that up now. Okay, so what are we going to do in our process, physics, and unhandled input? We're going to go ahead and we want to run, so like we have our current state, for example, right? If we said current state dot process, boom. And then we got to pass in our delta value here because it expects that. So what this is going to do is it's going to run this process in our player state. So then if we add code to like the idle state, it's just going to do what's in there. And then this also returns a value, right? So we could say variable new state equals whatever this returns, right? Which is going to be null most of the time, but eventually it'll be something like run. Okay. So that's okay. Let's go ahead and do that. And then next, all we have to do is call change state on the new state. Just like that. 2 lines of code. I'm going to copy these 2 lines of code and I'm going to paste them in the physics process and in the unhandled input. We do need to come through with each of these though. As you'll notice, this needs to now call the physics process on the current state, just like that. And this isn't going to call that. It's going to call handle input and pass in our event like that. Pretty simple, right? So anytime we have an unhandled input from Godot, the state machine is going to grab it and pass it to whatever the current state is. And then it's going to evaluate whatever that responds with. If it's null, then all's good. Just keep going. If it's a new state, then we'll change the state, right? I mean, we're always calling change state, but remember the first line is check if it's null. Okay. And then same for physics, process, and process. Every process frame that happens, our state machine is going to pass it on to our current state and evaluate the result, and with physics process. Okay. So that is our state machine. And this might be confusing to newcomers. I hope that this begins to make sense throughout this series because it's a really powerful way to build games. If you do it without this, I know from experience, the first proper game I tried to build was like a brawler, you know, kind of like Streets of Rage. And I didn't do this. I had like booleans and check, like, you know, if this bool is true, then that means you're jumping. And if it's false, then you're not. And I ended up having like 2,000 lines of code, and it was a buggy mess. And I got so frustrated with it, I stopped working on it. But this kind of a state machine here is going to really make your life a whole lot simpler. And even if you don't understand this state machine right now, as long as you can get it working like I have, and then are able to build a state that functions within it, then you're good to go. Focus on the states and make those work, and then slowly start to understand more about the code and what the state machine is providing for you. So what I'd like to do next is I want to create the script for each of these states. Now, we're not going to write all the code that goes into them. We're going to just start them as a boilerplate state that really doesn't do anything. Okay, and then we'll implement maybe the idle state and a basic version of the fall state. Okay, so we'll have that to go off of. But to start, I've got this states folder here. I'm going to right click and I'm going to say create new script. And I want it to inherit my player state. So I'm going to click that little button. There we go. And if I type player state, you can see I've got this player state option in here. I'm going to say inherit that. And then this state, we'll just name it the name of the state. And so let's start with the first one in our tree here, which is idle. So I'm going to just name it idle, just like that. And then if we look at this idle script, you can see that it extends player state. I'm going to go ahead and drag and drop this right on to idle right there. Okay. Now, one thing I do like to do that we don't have to is I do like to give these a class name, because there may be a circumstance in the future where you want to reference that. So I'll just call it player idle state. And I'm going to go ahead and go over to my player state, and I'm going to copy all of these from init down to physics process. I'm going to copy those functions and come into my idle state, and I'm just going to paste them. Okay. And then let's go ahead and just do something like on enter, we'll print entered idle state. Okay. So that we have some code to see if that's working. And then let's go ahead and copy that and put it on the exit as well, except we'll say exited. Okay. So it's going to do something. So we've got an idle state. We can go ahead now and assign this script to idle. Did I already do that? I must have already done that. Okay. So there we go. So we've got our idle, and then let's create a new version of the script for run, jump, fall, and crouch. So I'm going to take this idle and I'm going to duplicate it, and I'm going to call it run. Now, we may run into a couple issues with class names because we have conflicting class names. So let's change this to run state, and then we'll just update here. Run, whoop, and run. Okay, we'll go ahead and save that. We'll duplicate again, and we'll call this one the jump. Open jump, and I'm just going to do a find and replace. So on select run, and I'm going to do a control R, and you can see that it automatically populated my search term as run, and I'll replace that with jump, just like that. Okay, there we go. And I had case sensitivity off, match case, so it did find those other jump text, even though they had a lowercase j. Save that script. Let's duplicate run again, and we'll call this one fall. Open fall. And we'll just do the same thing here. In fact, we've already got that kind of set up, don't we? Rename that to fall. And we need one more, and that's the crouch state. So crouch. And I duplicated the fall state this time, so let me replace fall with crouch. Okay, there we go. hopefully I got that set up without issues. So I'm going to drag these on. The crouch state goes on that node, fall state, jump state, and run. Okay, so now we've got a state on each of these items for our state machine. Now, one thing I do want to do though, real quick, just to make this easy to use, is within our player state, which is the class that all of our states inherit, I want to put a way in here for us to reference the other states so it's easy to switch to them. And I'm going to come in here and I'm going to select all of my 5 states, and right click them, and I'm going to select this option that says access as unique name. Okay, which means we don't have to have a path to the node, we can just access it by its name. And I'm going to drag and control drop these into my state script, just like that. Okay, that means it doesn't matter where they are in relation to the script in the scene, it should find them just fine. So now I've got a reference to each state just by name, just like that, how I named the nodes. And I'm going to say that that'll be available to each state script within our state machine. Remember before our state machine, when it went to initialize, we printed out that we didn't find any states. Let's see what happens now. Okay, our game started and it found 5 states. Okay, awesome. Now, one thing that I'm not sure is I don't know why we didn't get it like an entered idle state, because I think that should have been the first one, but let's take a peek at our code and see what happened. So actually, you know, the issue lies right here with our change state changing to the current state. And this is not something I encountered as I set this up. And so it's actually a flaw in my state machine, so we'll have to address it right now. But when we initialize this, the first state in the array is the idle state. But it was already in the idle state, or that is already in that slot. And so when we have this change state, this second condition, if new state equals current state, then return, that's what's happening. So I'll just print this out so we can see already in this state, and then we can maybe print out the state, new state. So watch what happens here. So if I look at it, it says we're already in this state, idle. So it didn't switch to idle state because it thinks we're already there, but when we initialize this, we aren't. Okay, so let's go ahead and deal with this a little bit. Okay, so let's go ahead and, well, we can keep that here for now for debugging purposes, but let's go back down in our initial change state. So we've got this issue where we're trying to change to a state that we're already in when we start the game, and that's not going to work. And honestly, if we build all these states out, I think this will resolve itself because the idle will naturally flow into the fall state because we should be falling and so on. But just to be safe, let's just do one kind of goofy little toggle. Instead of changing to the current state, let's just change state to the previous state. Okay, so it's going to go from idle to the next one in the list is going to be run. And then we'll just do that again, because what will happen is run will go first and then idle will become second in the array. And so it'll become the new previous state. So if we just change state twice, we'll end up in the original first state. And if we look back, we can see, here we go. We found 5 states, entered idle state, entered run state, or exited idle and entered run. And then we exited run and entered idle. So there we go. So this is something that I'm not like amazingly disappointed in or happy with. I wonder if there's a better way, but if you have any thoughts, go ahead and drop them in the comments. But you could probably be fine with just changing to the current state to begin with once this state machine is all built out. But certainly for our current state of the code, we kind of need to do this. And this isn't going to break anything when we begin either, unless your first state is something that you can't really exit. But yeah, this should be fine. Now, another option, though, that what we could do here is we could always just kind of toggle it to change to, like, we could set it to do like a state that we know is harmless, like crouch. And then we could tell it to go to current state.idle. Something like that. I wonder if this will work as well. It should. Okay, so he went to idle, from idle to crouch, then to crouch to idle. Okay, so there's just a way to kind of initialize it, pick some states that are safe. All right, so let's go ahead now and let's move forward. Let's go to our idle state. And obviously we don't want our player to be running in place anymore. We made that the animation that he starts on, and we can change that. But just to show that this is working, let's go ahead and our enter. Something that we're going to do on just about every state is we're going to call our player and grab the animation player, right? If we look at our player script here, we have a reference to the animation player right there on line 8. At least for me, it's line 8. So we'll grab that animation player and tell it to play the idle animation, right? Every state has an associated animation that it should play. So now if we run the game, whoop, there we go. He's in his idle animation now, which is no animation at all, but there we go. We have it. So we know that this state is properly being entered, and we're seeing that this enter functions as we expect, as well as the exit, because we can see the debug print that we're getting entered and exited. Now I want to do one other thing here in the idle state. So there's a nice functionality that we have on our player. Since he's a character body 2D, let's go ahead and just take a look at this. And I do that by control clicking on the class name. If we look in here, there's some interesting properties and methods that we have. And one of these is, let's see, let's go down here, is on wall and is on floor. This is the one I want. See, this is on floor. It's going to return a Boolean true or false. And we can make use of that in our idle state. So in our physics process, we're going to do a little check. We're going to say if not player.is on floor. Okay, that should be under here. Right, which is just the same as saying if the player is not on the floor, then we're going to go ahead and return the false state. So anytime we're in the idle state and we're not on the floor, we should return the false state. And let's go ahead and go over to our fall state and let's have it play the fall animation. So we're going to say player animation player dot play. And then we have an animation called fall. So now if we run the game, phew, he was falling. He never went back to the idle state. But that's good. I mean, we did make some progress, right? So the player exited idle, where is it? And went to the fall state down here. Obviously, when we're falling, we need to eventually, when we hit the ground, when we are on the floor, we need to go back to our idle state, okay? So let's go here into our physics process for this fall state, and we'll just do kind of the opposite. We'll say if player dot is on floor, then we'll return idle. I'm going to go ahead and save this and run the game again. Boink. There we go. So now he went from falling to idling. Now that's going to conclude what we're going to work on today, because this state machine was a lot to wrap around, so I hope that you're able to work through the code and get this much working. In our next video, we're going to implement the run state so that Marlowe can move left and right, and so you'll see how he'll be able to run off of platforms and things like that, and then we'll add on to our player state machine from there. If you enjoyed this content and you're learning, please give me a thumbs up. Subscribe to my channel if you want to see what's coming next. And as I mentioned earlier, if you want some help and want to dig into these things, join the Discord channel. We've got an amazing group of people in that channel who love to help out and answer questions. And it's just a great environment to learn and kind of talk about common ideas and questions and problems you might be encountering in your projects. So thank you for following along. And as always, we'll see you next time.